Alright, so I want to start today with a couple of practice problems before you guys practice on your own. This first one here, we want to find the limit analytically. If it exists, confirm graphically. Okay? So here we have the limit as x is approaching 2 of x squared minus 4 over x cubed minus 8. What do you get if you plug in 2? 0 over 0. Alright, so we've got to have something else that we can do. Alright, yeah, we've got the difference of squares on the top, so it's an x plus 2x minus 2. How's the bottom factor?
X minus 2 x squared plus 2x.
Good. Good memory. Alright, so we factored our difference of cubes. This is one of those things that you do just have to memorize, okay? There are a few things you just have to memorize, other things we can figure out pretty intuitively, alright, if we forget them. So now we can reduce that, and now we can try plugging in 2. So what do we get if we plug in 2 now? You got 4 over 12?
Yeah, 1/3.
Okay. Yeah, and we should reduce. So we get 1/3.
Could you not factor the bottom again to get x plus 2 squared and then do 1 over x plus 2, which is 1/4? Like it's just that, not like.
Well, check your factoring there. If it were x squared plus 4x plus 4, it would factor that way. Yeah. Alright, so there's number 1. Now, down here I've reminded you of the two properties, the two limits that I told you yesterday you'd need to memorize. So with those in mind, look at number 2 up here. The limit as x approaches 0 of sine of 4x over x. What do you think we do with this?
Yeah, when you.
What?
You have to try to get rid of the 4 somehow.
Try to get rid of the 4
So it's just
somehow.
sin of x over x.
Just erase it. No,
Just
No,
erase it.
obviously not. Okay. Yeah, I would.
Well, no, I mean that's natural, right? Because this says the sine of x over x, right? And we've got sine of 4x over x. So what can we do to fix it? Is there a way to get the 4 out?
Can you divide by 4?
Well, that's the same thing as 4 sin x.
Well, let's try that. If I divide by 4, that's going to make that. Am I allowed to just randomly divide by 4 whenever I feel like?
No, but I would do it.
No, but what am I allowed to do? If you do the top and the bottom by the same thing, that's okay. So look at what we'd have. We'd have 4 times sine of 4x over 4x. Did that help us?
No.
You don't need to do it.
Then you did the 4 is just equal. Wait, no, you don't.
Because I'm forced.
That just brought more stuff.
Don't you not have to do anything? Because it's going to be 0 over 0 anyway. Sine of it.
Well, that's the reason why we have that one that we developed with the squeeze theorem,
Yeah.
is because, yeah, it's 0 over 0, but we got to have there actually is a limit here.
Could you?
Isn't it 1?
Cancel
Okay.
Is it not 1?
This is where, oh, you have an idea?
Consider 4x as the inner equation function. Like,
Oh, I get what you're thinking, because we had the theorem with composite functions. That's not a bad thought, except we don't want to just take the limit of the top divided by the limit of the bottom. And that's what we would kind of have to do if we were going to use that composite function. We actually got the correct first step here.
Oh, you would.
Believe it or not, that's the way you want to start this one. Okay? Remember, the other thing we looked at was that if you're multiplying two things, you can go ahead and take the limit of the one and just multiply it by the limit of the other. Okay? And by the way, Gloria, actually there wasn't anything wrong with what you were suggesting, but that still would have ended up giving us 0 over 0. I'm sorry. It is okay to take the limit of the top and divide it by the limit of the bottom. It's just that doesn't help us in this case.
Don't you want it to be 0 to 0? Because that says it equals 1, the limit.
Well, does 0 over 0 equal 1?
Well, sine of 0 over 0. Because there it's sine of 0 over 0 equals 1. So wouldn't it be the same thing there?
Well, but that's the thing. It's no, we didn't get that by evaluating. Okay? And it goes back to the value of the limit is independent of the value of the function. The function is undefined when x equals 0. But the function does actually approach a value in this case. Yeah.
Could you use, there's a, like the double angle form, like sine of 2x is cosine x times sine x? Would that be something you could use?
2 sine x cosine x, so it'd be 2 sine of 2x times cosine of 2x. We might be able to get there eventually, but there actually is an easier way. Check this out. Okay? Let's say I rewrite this as the limit as x approaches 0 of 4 times the limit as x approaches 0 of the sine of 4x over 4x. Okay? Now, what's the limit as x approaches 0 of 4? 4. So now we just need to figure out the other part. What do you think it equals? 1. Okay? If x is approaching 0, what's 4x approaching? 0. So, could we also, like, think of it that way? Don't write that, but could we think of it that way? Basically, as long as the angle matches the denominator with the sign here, it's going to approach 1. Okay? So, that equals 1. 4 times 1 is just 4. Okay? And if you think about it, limit as theta approaches 0 of sine of theta over theta, here theta just happens to be a 4x. Right? Do a little substitution there. Okay?
But how are you able to separate the limit of 4 on that approaching 0 from everything else?
We saw that yesterday when we were looking at some of those warm-up ones. We had like x times cosine x. We could take the limit of x and the limit of cosine x separately and just multiply them together. So, yeah.
So I was trying to prove that with the calculator, saying sine of x and then sine of 4 times x. So I said x equals 1, so the sine of 1 is sine of 4, to see if it would be, if the 4x would be 4 times that of the x. And it was 2 when I put it in degrees, but when I put it in radians, that wasn't true. Is there a reason for that?
Well, everything that we do is going to be in radians, okay? So let's actually graph this. Make sure I'm in radians. Yep, I'm in radians. Okay? So let's graph the sine of 4x divided by x. Okay, the original function. And I want x to approach 0. Alright, so I'm going to zoom in here and then I'll show you what we've got.
4x over x? What's your x in?
The original problem was the sine of 4x all over x. Okay? So, let me put this in here. Alright, so here I've got it graphed, and I actually use zoom box. If you don't know how to use that, that's really cool. Zoom box, and you move the cursor to one corner of where you want the window to be and hit enter, and then use the arrow keys to move it up to the other corner. And then when you hit enter, it'll change the window to just be what you boxed. Okay? But if you look at this, it actually looks like it goes straight through the 0.04. But if we were to trace this and try it right at 0, you can see it's undefined. Okay? But the limit here is approaching 4. See there, just to the left it's 3.98. Just to the right it's 3.98. So it does actually approach 4.
I messed it up.
Alright, so does this make sense? Okay. You can be flexible with these formulas and work with them. Limits are actually very flexible. You can, if you have things multiplied, you can separate it into two different limits multiplied. If you have things in there that are added, you can separate it into two separate limits that are added together. Because the limit of a constant is always the constant, I could just pull that 4 out and not even bother taking the official, like writing down the limit as x approaches 0 of 4. I can just pull the constant out. Alright, so limits are very flexible to work with, and we'll pick up more and more properties of them as we go. Okay? Alright, so at this point, that's all I wanted to do together, and at this point what I want to do is work through some of these samples, these practice problems together in the group. So if you're with, most of you are with groups, go ahead and get with groups if you're not, and let's work through these and ask questions and just practice. Okay? That's the only way to get done with it, or get good at these, is to practice.
So